The aim of this video is to revise and consolidate our understanding of expansion. But first, we need to lay down the foundations. We have to revise the rules of indices, and we have to make sure that we understand how brackets operate. As you remember, there are a few rules of indices, the most important of which is when you multiply two quantities with the same base, you add the powers. So for example, x squared times x cubed, the base is the same, you add the powers. So the answer is x to the 5. Similarly, when you divide, you subtract the indices as long as the bases are identical. So for example, x to the 7 divided by x to the 4 is equal to x to the power of 7 minus 4, which is 3. And finally, when you raise a quantity to the power, you multiply the two indices. So for example, x squared to the power 3 is equal to x to the 6. You've done these rules before, but it's worthwhile mentioning them. Now let's understand brackets. We mentioned earlier that x plus 5, written in this form, is an expression made up of two terms, and that the brackets sort of group the things together, and this is made up of one term. So let's understand the difference between 2 times the quantity 3x minus 5 and 2 times 3x minus 5. Obviously 2 is multiplied by the bracket. However, because it's before the bracket, it means that it's multiplied by everything in it. So some people do this to remind you that the multiplication is distributed over everything that's in the bracket. However, this is a rather primitive way of expressing things. You can simply say this is equal to 6x. 2 times 3x is 6x. 2 times negative 5 is minus 10. However, 2 times 3x minus 5 without the brackets means that the 2 is multiplied by the 3x only, and this is 6x minus 5. Also, negative 4 times 2x plus 3 inside brackets. Remember that you multiply the negative 4 by 2x, which gives you negative 8x. Minus 4 times 3 is negative 12, so there's a minus 12 here. Whenever you multiply a bracket by a negative quantity, the signs inside the bracket change. And this simply means that you are multiplying the bracket by negative 1. But you don't need to write the 1, and this really means negative 5x plus 1. Now, if we look at this expression and we want to consider the effect of the brackets, we notice that the brackets are really not adding anything, because you're adding x plus 4 to 2x minus 3. And in this case, the brackets are optional. Their presence changes nothing. You could have equally written this as x plus 4 plus 2x minus 3. And this would equal, by collecting like terms, 3x, x plus 2x, 4 minus 3 is the 1. However, in this case, the first brackets are optional. But because there's a minus, you're subtracting everything that's inside the bracket, then the second brackets are necessary. In this case, what you have is 3x minus 4. Obviously, those brackets are optional, but because there's a minus before the bracket, it's minus 2x plus 1, because you're subtracting 2x minus 1, and when you subtract the negative, it becomes a plus. So this equals 3x minus 2x is x, negative 4 plus 1 is negative 3, so x minus 3. In this case, both brackets are necessary, we expand each of them and we simplify by collecting like terms. This equals 4x plus 8 plus 3x minus 3, and then you collect like terms, giving you 7x plus 5. Note that you don't need to write those arrows. Let's get to expansion then. Now this expansion is a bit more complicated than just having a number outside the bracket. We have a product of two brackets. And in this case, this x is multiplied by everything inside this bracket, and this 2 is multiplied by everything inside this bracket. This gives us x times 3x is 3x squared, x times negative 1 is minus x, 2 times 3x is positive plus 6x, 2 times negative 1 is a negative 2. And obviously we have two x terms, so we can simplify by collecting like terms, and this gives us 3x squared plus 5x minus 2. Note that what we have in this bracket is a linear expression, and what we have in this bracket is a linear expression, and the product gave us a quadratic expression. Keep this in mind. A linear times a linear will give you a quadratic. Now let's consider a quick shortcut. Now I know that I have a linear times a linear, and that should give me a quadratic. So I know there will be an x squared term, an x term, and a constant. The x squared term can only come from the product of the 3x times the 2x. So that's 6x squared. I have an x term, but the x term comes from the product of the minus 1 times the 2x and the product of the 3x and the 4. So mentally, I can think of this product as 12x, the 3x times the 4, and the negative 1 times the 2x is minus 2x. So I can do this in my head and say that this is a plus 10x. And as far as the constant term is concerned, it can only come from the multiplication of negative 1 times 4, so that's minus 4. If you're confident with this shortcut, you can do it. It saves a lot of time, and it seems professional. Now there are some special cases. We have the difference of two square expansion. It's a linear times a linear, and it gives a quadratic, obviously. Let's consider the x squared term. It results from the multiplication of x times x, and that's x squared. Now, as far as the x term is concerned, we have minus 2x from the product of those two, and 2x from the product of those two. So they cancel out. And if we write it out, minus 2x plus 2x, those cancel out. So the constant term is what remains. Minus 2 times 2 is the minus 4. So how do you identify a difference of two squares expansion? You have a linear times another identical linear. The only difference is that the sign in one bracket is plus, the sign in the other bracket is a minus. Another special case is the perfect square expansion. This is basically saying that we're multiplying x plus 3 times x plus 3. And if we do this using the shortcut, x times x is an x squared. We have a 3x when we multiply those two terms, and another 3x. So we have two 3x's. That's 6x. 3 times 3 is a 9. And the shortcut goes as follows. If you have a perfect square, the expansion is the first term is squared. You add 2 times the first times the second, which is plus 2 times x times 3, which is 6x. and the other term is squared, which is 9. Now I would like you to think about how you can generalize those two results, express them in general terms. Now it's time to learn something new. If we multiply a linear by a quadratic, the same rules apply. X is multiplied by everything in this bracket, and 2 is multiplied by everything in this bracket. So, x times 2x squared is 2x cubed. X times 3x is plus 3x squared. X times negative 1 is minus x. Now we take the 2. 2 times 2x squared is plus 4x squared. 2 times 3x is plus 6x. 2 times negative 1 is minus 2. Now we note that we have an x cubed term. We have 2 x squared terms and 2 x terms. So we collect like terms. 2x cubed. 3x squared plus 4x squared is 7x squared. Negative x plus 6x is plus 5x. And the constant is minus 2. Now I would like you to think about a shortcut that will spare you the need to write this out. Can you think of a way to do it? And finally, we have an example such as this one. We have an expression made up of two terms. This is a term and this is another term. And we want to expand and simplify this expression. It is very important, extremely important, to remember to keep this operation until the very end. So we have this minus. 2x times 2 times x minus 5 is 2x minus 10. That's the expansion of this bracket. We have a minus 3. We have to think of the expansion of those two brackets first. And it's a good idea to do them using the shortcut. So 2x times x is 2x squared. As for the x term, we have an x times 1 and an 8x, which comes from the 4 times 2x. So this is plus 9x. And then we have 1 times 4, which is plus 4. And now we can expand. We have a minus 3 multiplied by this bracket. So we have 2x minus 10 minus 6x squared minus 27x minus 12. And to collect like terms and simplify this expression, it's a good idea to begin with the x squared term. So minus 6x squared. We have 2x minus 27x. That's negative 25x. We have negative 10 minus 12, so that's minus 22. Of course, you could have moved from this step to this step by doing this expansion mentally.